Hello and welcome to another video. Today we're going to be talking about missing data or null values, which is something that can occur in your data set, like when you give out a survey and people don't fill out certain parts, when you're merging data sets, or for a variety of other reasons, null values can make their way into your data. And this is a big problem for data scientists. So we need to know how to take care of these null values and get rid of them. So that we can use our data for machine learning models or other useful things. So the first thing we'll do to get some practice with this is load in pandas and then load in this new data frame from Kaggle on mental health in the tech industry. You can read more about it here. And just note, I did add in some null values to this, to a couple of the columns of this data set. So then we can look at the head of this data set. We have temporal data like timestamp, numeric data like age. We have categorical data like state, binary data like family history, which looks to be like a yes or no. And then we also have this ... That shows that not everything is being displayed in this Jupyter notebook, that there's not enough space to display all the columns. So let's just look at the columns and see what all there is. So that's pretty cool. Now the first method, there's two different ways to deal with NA values. We can either remove them or we can fill them in with something else. First, we're going to talk about removing them. And within removing NA values or null values, we can basically do two different things. If there's a column with a lot of null values that isn't too important to us, we can simply drop the column. We're not going to go over that here because we've dropped columns plenty of times before in this series. But the other situation is where the NA values are spread out more, and so we have to drop the rows that have too many NA values. And that's what we'll focus on here. But first we have to know that there even are NA values to be worried about. And we can use a mask like we learned about before, but just in this case we're using it to find NA values. So we'll run this mental health self-employed.isNA, and it's going to return a series of trues and falses depending on whether self-employed is NA or NaN for not a number. We can run that, and then we put our mask into mental health, and we'll get the head of that resulting data frame. And I have all those places where self-employed is NaN. So that's useful to us. We now know that there are null values we need to clean up, at least in this one column. But what say we want to look at every column? We can use a for loop. We can use for column in mental health columns, which is going to loop through every column. We'll print out which column we're dealing with, and then we'll print out whether that all the places that column has NA values. So first of all, we see timestamp has no NA values in it. Pretty good. But age has a lot of NA values in it. Not so good. Country, no NA values. State, plenty of NA values for us to deal with. Self-employed, plenty of NA values for us to deal with, and so forth. That's a good way to look through all the columns and see what has NA values in it, or null values in it. So how do we actually get rid of them? Well, we can use the method drop NA on our data frame. That's going to drop the null values everywhere. Everywhere there's a null value, that row gets gotten rid of. And then so we can do that and then look to see how many null values are in the state column, which should be 0 because we dropped all the NAs. So let's check that out. And just like we would expect, all the NA values are gone. So that's great. We may not want to drop null values everywhere. We may just want to drop it for specific columns, or drop the rows where specific columns are null. What we can do is drop any but pass in this subset, and then a list of all the columns where we want to drop NAs from. Let's call that list less NAs and display it. Okay, so where we have state, that has no NA values anymore, or NaN values, and then work interfere has no NaN values. So that's good. So that's how we drop NA values. The next method is going to be to fill in the NaN values. And there's several different varying degrees of advancedness ways of dealing with this. The kind of trivial, naive approach would be to simply fill all the NAs everywhere. That's what this first line of code here is doing, and we'll build onto this function to do more complex and useful things for us. But first, let's just try filling all the NaN values with 0, which is what this is doing. Fill NA 0. So we notice everywhere that there was an NA, it's now a 0, even in the comments over here. So that's great, but we can maybe do this on just a specific column we want to fill in the NaN values with a particular value like 0. So first I'm going to make a copy of our data frame, mental health.copy. This way we can, after we've tried this out, we can go back to our original mental health data frame and look at different ways of filling NAs. So we'll make a copy, and then on that copy we'll replace all of the whole self-employed column with a new self-employed column that has fill NA with 0. And then we'll look at that. So now just for the self-employed column, all the NAs are filled with 0s, but not for something like state. And then we can look at all the places where age is NA. There we go. Now remember, age is a numeric column, so we can do some special things with this. In particular, we can fill all the NA values with the mean of age. And what's going to happen when we add more of the mean? Well, the mean isn't going to change. That's what's going to happen. So this is one way we can not impact the mean or the center of our data by adding just more of the mean to it to fill in those NA values. So down here, let's do that with this line of code. Right here, we're going to take the age column, we're going to replace it with the age column where we're filling in the NAs with the mean of the age column. And then before that, we'll check what the mean is, and after that, we'll check what the mean is, just to make sure we haven't changed the mean. And then we'll print out everywhere there's an NA value in age, which should be nowhere. So let's try that out. So yep, our mean is the same, and we have no NA values. But this is a rather large mean for age. So let's check out the max value of age, because this seems a little high. Yep, so the max value, someone typed in 9999999 on this survey for their age. Probably not correct, and we'll learn how to deal with these high outliers or noisy data in a later video. But for right now, we'll just not worry about that and keep moving on with the null values. So as I said we would do before, we'll reset our mental health copy to the original mental health data and start over with a different method of filling in NAs. This will be fill NA method ffill, which stands for forward fill. This is going to take all the NA values and fill them in with whatever was before it. So let's check that out. Notice in the state column, IN is here, and there were 2 null or NaN values down here. But because IN is up here, IN gets filled down here. Also notice that self-employed, there's a bunch of NA values still here. And that's because there's nothing above it to fill them in. So what we can do is we can do a backfill right after we do our forward fill, a bfill. And what that'll do is that'll take care of all the NA values at the beginning. There we go. Notice our data frame looks a little bigger because we're now having backfilled all these comments that people had that used to be short little NAs, and now we're filled in the comments. Realistically, we'd probably drop the comments column altogether. That being said, let's look at resetting our data frame so we can try yet again. And then now what we're going to do is focus on this state column. Because this is a categorical variable, one method we can use is filling in with the most common value. It's kind of like filling in with the mean. Filling with the most common value isn't going to change which value is the most common. So what we can do is look at this state column, and then get the value counts, and then ID x max. Don't worry too much about this particular syntax right here. Just know this is how we're going to get the most common value. And yep, California, or CA, is the most common value. So what we'll do is we'll fill NA with the most common value, CA, and then we'll look at that. Yep, and down here where we had two NaN values, we now have CA. One last method we can do to fill in NA values, and that's interpolating. This is only for numeric data, and it's basically treating the numeric data as the output of some smooth function, and then trying to fill in where those missing pieces are, or those null values are, assuming it's some smooth function. Good for something like something based on time series data. So let's try that out. And notice now age seems to be filled in, but the other categorical or binary data is not filled in. So let's just make sure age doesn't have any null values anymore. And it doesn't. Empty data frame. That's good. And that's all for this video. You now know every common method for filling in null values and getting rid of null values. And you're all ready to go to clean up some data sets. Super excited to share this knowledge with you because it's a really important part of what a data scientist does. Thanks for making it all the way to the end, and I'll see you in the next video.